the power losses is a square root of current. So higher the current, more will be the losses. Now the peak currents are going from 300 amps to almost 2000 amps. AI is nothing new. Industry has been talking about AI for 50 years now, but everything changed in 2017 when Google came up with the transformer model.
This is the podcast for engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor industry. Today we're talking about AI and as part of our We Power AI series. I'm joined today by Athar Zaidi, the Senior Vice President and General Manager of Power ICs and Connectivity Systems at Infineon. So welcome to the podcast. In our previous episode, we talked to Adam White about AI and how the increasing demand for this is putting more pressure on our data centers. Now I'd like to talk about a little bit more about this power hungriness of AI and the implications it has on our data centers. Can you explain what's driving it?
Yeah, sure. AI is nothing new. Industry has been talking about AI for 50 years now, but everything changed in 2017 when Google came up with the transformer model. And then our life has changed since March last year when GPT-3 was launched. And since then, all the metrics, all the forecast has been wrong. So we are living in the world of AI. AI means power. There is no AI without power. And why is that so? For a very long time, the average power consumed by the processor used to be anywhere between 150 to 250 watts. With AI accelerators, that number has grown astronomically. It went to almost 700 watts today. In next 2 years, that number is going to be 1500 watts, going to 2000 watts. Why is that important? Power is voltage times current. When you're talking about voltages, the processor voltages are coming down as industry move towards finer nodes, which means for the same power, the current has to increase. And the power losses is a square root of current. So higher the current, more will be the losses. Now the peak currents are going from 300 amps to almost 2000 amps. And that's where it is very important to make sure that these systems are energy efficient so that we are not wasting power in heating the air around the processors. Mm-hmm. And this trend is not going to slow down because AI is power hungry. And with large language models and GenAI, we are just starting the journey. And if you're not careful about the power, then there is a real danger of the grid getting collapsed.
Yeah, I know from personal experience that ChatGPT and these large language models, you can't even imagine a life without them nowadays. But can you put it into perspective for us? How much does a large language model demand in terms of power compared to something else?
Yeah. So it's the power and it's the expense, which is the total cost of ownership. So just give you a perspective. It cost Google almost $1 million to learn a model which is called Transformer in 2017. GPT-4 cost OpenAI almost $80 million.
Okay.
And that happened in the period of 5 years. And now we are talking about a next generation transformer, a large language model by Google called Gemini Ultra, which is costing them $196 million.
Okay,
so
wow.
Going from 1 million in 2017 to 196 million in 2024, it's the total cost of ownership, which is a big deal. Now, AI is a buzzword. The challenge for all the hyperscalers is how to monetize it. And total cost of ownership, which is in terms of paying the electricity bill, the cooling bill, is becoming a big operational cost in running these data centers. So the semiconductors, these are the components which power the processor. And we are losing roughly 10 to 12% of efficiency because the innovation in the power topologies are lagging compared to innovations in compute.
Okay, so how is this changing the infrastructure of data centers then?
For example, if you look at the Hopper family, which is from NVIDIA right now, you're talking about 700 watts in a very small amount of area. So power density is becoming a big deal. There are changes in the topologies. So the old ways of taking 240 volt from the grid and converting into 1 volt in the processor has changed dramatically. There is something called 48 volt systems where it is much more beneficial to transfer the power at a higher voltages because the losses go down. So it needs re-architecting the whole data center. Google started with it on 48 volt system a couple of years ago, and it was a very niche market. Now 48 volt systems is a mainstream, but that's not the end. The whole power supplies which is coming from the grid has to be re-architected in order to support the energy demands going forward.
Okay. Yeah, I think we have an upcoming episode on 48 volts architectures. What about these AI data centers? What is the status quo today, and how do you see them evolving in terms of hardware and software then, besides the topologies?
Right. So data center is consuming roughly 3% of world's electricity today. If the brute force AI continues, it's expected that the demand is going to be 10% year over year. So by the end of the decade, it'll be 7% of the world's electricity.
How many?
7%.
Oh, wow. Okay,
and just to put it in perspective, that is the amount of energy that India consumes. So the data centers are going to consume as much energy as fourth largest economy in the world with 1.4 billion people. So that's the scale that we are talking about. Any improvement in efficiency helps the planet here, because the carbon footprint on these data centers, especially on the GenAI, is very, very large. And the incremental innovation days are over. We are thinking in disruptive innovation from the grid to the core. That's why we are thinking about changing the architecture on the power supplies all the way to the DC-DC conversion, which is required to power these very complicated processors.
Okay, yeah. So the impact isn't just on the total cost of ownership for these data center operators, it's really on the world. We talked a lot with Adam about carbon footprint and energy efficiency, but how can we be really more energy efficient in data centers?
So the beauty here is that even 1% improvement in the efficiency translates to tens of millions of year reduction in the carbon footprint, and it translates to tens of terawatt hour of energy which can be saved. Just to give you an idea, Google and Microsoft, they are consuming roughly anywhere between 30 to 50 billion liters of water in cooling, which is equivalent to a consumption of a city in a developed world that has 800,000 inhabitants, which is like city of San Jose. So it's not only power, it's everything around power. Is the extraction of heat from these data centers as well. So today, the power is built around the processor, which is an old way of doing things. And every millimeter of the board space matters. And at Infineon, we are looking into re-architecting the power delivery system. So instead of powering around the processor, we are planning to put the power underneath the processor itself. So the distance traveled by the current is minimized. That leads to improvement in the efficiency as well. So that is one part of the equation. The other part of the equation is the innovation in the material itself. So Infineon has been on this trench MOSFET journey for about 20 years now. We have best-in-class power switches, and we continue to innovate on them. Just to give you an idea, the latest power stages from Infineon use silicon. The thickness of that silicon is 1/5 the thickness of the human hair. 20 micron, and that is not the end of it. So thinning these MOSFETs is one thing, packaging them is another thing, and then packaging them at scale is a very difficult problem. So Infineon has roughly 1.5 billion of these power stages installed in the data centers worldwide. Doing it that scale and making sure that these power stages don't fail, and the customer put these power stages in their system and they don't lose sleep on it, is a very difficult problem to solve. And why is that important? Because the ROI for the end customer is very high. Just to give you an idea, if you look at Amazon does tens of billions of dollars of business on a prime day. So in 48 hours, they did say $20 billion in revenue. Alibaba on Singles Day, which is 11th of November, they did anywhere between 50 to $80 billion. They run, all the business runs on these servers. Most of them are powered by Infineon. Imagine if these servers fail, the cost of those failures per minute is literally millions of dollars. So
Wow,
that's why
yeah.
the robustness, the efficiency, the reliability is very important. Just to give you an idea, a latest accelerator cards from the biggest AI company in the world can cost anywhere between $30,000 to $40,000. One of them.
Okay.
Meta has spent almost $18 billion in training their Llama 2, and it's only 600,000 of these cards. So that's the scale that we are talking about.
Mm-hmm.
Our content on those boards define the reliability of the system. So these power stages not only need to be super efficient, but they need to be reliable and robust so they don't fail in the field.
Yeah, you need to count on them because a failure means a big loss financially as well.
Absolutely.
Okay, so what about the is there room for improvement in terms of efficiency? Because you've mentioned already how we are working on it on our products and how you can change the materials and also the topologies. Is there still anywhere to improve from here?
Absolutely. So our calculations show that the lowest hanging fruit that we have is re-architecting the system, which has not been done at scale right now. There is a potential to save roughly 8 to 10% of power on the board. And
Okay.
think it of as a butterfly effect. A 1% on a improvement in the efficiency on a board gets multiplied when it goes to a rack, gets multiplied when it goes to a data center, it gets multiplied when it goes to a cluster.
Mm-hmm.
So you start with 1% at the board level. By the time you are at that scale, you're talking about millions and millions of dollars in saving in the total cost of ownership. And it translates to a reduction of the carbon footprint in millions of tons.
I love that these small products and the optimization of small products have such a big
Amplification
impact.
effect, yes.
Yeah, very nice. What does it look like on a worldwide scale? How are data centers doing globally when it comes to energy efficiency? Are there any goals or regulations?
Not yet. It is expected that 80% of all data center power will be consumed by 4 or 5 hyperscalers only.
Okay.
So even if one hyperscalers take a lead in this, it will have a material benefit on planet Earth. The grid, as I said, is the increase in the power is only 2%, but the demand is roughly 10%. So you can see that there is a big discontinuity on the speed at which grid is all going to operate versus at the speed at which the energy is going to be consumed, to an extent where Microsoft is partnering with companies who are working on nuclear fission and fusion reactors, because these data centers need to be close to the source of generation of electricity. It has become such a big problem now.
Okay.
As Adam mentioned, City of Ireland, or country of Ireland, for example, they are saying no more data centers. There are no more data center in Singapore. There is no more data center in Northern Virginia, because these data centers are consuming as high as 30% of the energy generation in these towns, and there is nothing left for the people anymore.
Okay, yeah, it's you really see the actual concrete impact that it has on the areas. We talked a lot about hardware and architecture. Is there anything on the software side of things that we can do?
So everything has to be intelligent. For example, think about a race car. If you are driving a very high-end race car and you look at the odometer and tachometer of the race car, and there is always a red line, right? You can't go higher than that. Mm-hmm. If the system is faulty, and if the power is not as high and you get red line, then you have to artificially throttle back. On the other hand, if you are under reporting, then there is a clear danger of the engine getting burned. So what in industry term we call it telemetry. So telemetry is the smarts that we build around our power solutions that talk to the processor and tell the processor what to do. So everything has to be joined together in a smart control. And in Infineon, we are the pioneers of digital power. Normally, the processors can do much more than what the power can support. So normally, power is a bottleneck. And by doing an efficient management of the power envelope, you can extract more out of the system. The other benefit of the smart control in the system is that you can optimize the utilization of the data centers. For example, think it of a way that if it is a predictive signature in the system that the demand is coming. So you ramp up these data centers, and when the demand goes away, you ramp them down. So the benefit of that is you bring the average power consumption of the data center just by efficient management of the power in a smarter way down, which again translates to carbon footprint saving, it translates to energy consumption saving, it translates to total cost of ownership.
Okay, similar to how you have on the grid peak demand, and so that the software and the control can really help regulate the data centers and make them more efficient that way.
The challenge here is the ramping up and ramping down of the data center is not a trivial problem, because if you get this wrong, then bad things could happen.
Okay.
And it has to be done in an intelligent way. Believe it or not, AI is being used in management of these data centers as well from the power side.
Okay, so you definitely need reliability across the board for these data centers. Okay, so coming to a designer perspective, what metrics are processor designers looking at when it comes to these systems?
So there's something called Kumi's law, and what it says is that the amount of energy which is consumed to do certain computation is reducing by half every 1.5 years.
Okay.
So you can do more teraflops in future with a certain power consumption than what you're doing today. Unfortunately, the designers of these accelerators are only thinking about throughput. Power for them is after the fact. It used to be okay because power was catching up, but the trend has changed in the past 2 years or so. Pretty much every processor company has realized that power is a bottleneck and power cannot be afterthought. So those designers which are designing these very complicated, very powerful chips have to think about power first.
Okay, so it sounds like the future is power first then. So Infineon has already been playing an active role, obviously, in shaping or addressing the power struggle in AI data centers. What are we doing, and what can we do as an industry to address it together?
So there are a couple of things that can be done. First is drive the sensitivity of power first, and power cannot be afterthought. And why is that important, and why I believe it's an opportunity as well. So hyperscalers, by definition, are the experts in the software. Now, these hyperscalers are becoming hardware customers. Every hyperscaler has a plan to do their own silicon, to customize that silicon based on their needs. They don't understand power. So it's an opportunity for people like us who have been doing power for so long to educate them how to do efficient power management. So that's number one. Number two is we can take a lead in defining the industry footprints, industry form factors. And why is that important? Because continuity of supply in these data centers are very much important. So by having the common footprint, we enable the ecosystem, we encourage our peers as well to innovate, and then we can together serve the industry in a better way.
Okay, that's great to hear. It sounds like as an industry, we can really come together to shape a better future for AI data centers.
Yeah, and the term that I always use is not competition, is co-opetition. So you cooperate and compete at the same time.
Yeah, that's what we like to see. So thank you so much, Athar, for being here today. And thank you so much to our listeners for participating. We would love to hear more from you. If you have a question on AI or you'd like a deep dive on a specific topic, please send us an email at wepowerai@infineon.com. You can find the email in the show notes. And please stay tuned for more episodes on AI. Thanks a lot.
Thank you.